Hi, before we go into our next lesson, we're going to review commutative and associative property. They gave us an expression and then we have to simplify it, which I already unveiled, and we need to write the reason based on what has been done for each step. So for the first one, it's given. Now the second step, we notice that the 7 and the 10 is grouped together rather than the 3 and the 7. So when you're dealing with grouping, it's the associative property. Next step, you see that the 7 and 10 are together, but instead of being second, they're the first in the line. So we're switched with the 3. So switching, the property deals with switching, is commutative. Then now we see that the 17 has been replaced, 7 and 10 has been replaced by 17. Something's being replaced, you are substituting it. So substitution property. And then now you just added the 17 and the 3 to get 20. 20 is the same as 17 plus 3, so it's substitution. Right. So now we have a picture. Before starting our lesson, we have a picture showing a mother with 3 items and then other little shapes with the same 3 items. They want to know, what do you think is happening in this picture? So you're going to have different interpretations on how you view this picture and what's going on, or create your own story. For me, I see that there's a mother, and then the 5 circles, I'm assuming that is her kids. And the 2 squares, I'm going to label them as cousins. The 5 kids and the 2 cousins each have 3 of the items that the mother either bought or she has. So I'm going to assume that the mother bought this item and gave it to her 5 kids and then also to the 2 cousins. So if we go to the next thing, it says, can you create an expression to relate to this picture? All right, so we're going to use numbers to deal with this expression. So there's a mother, and then she has 3 items. So what I'm going to do, I'm going to get my pen. I'm going to use black for this one. Actually, no, not black. Use red. So there's a mother that has 3 items. So she's got 3. And she's got 5 kids, and she's given those 3 items to those 5 kids. So I'm going to put 5. And since the cousins are not, they're part of the family, but they're not her kids. Could be her sister's kids or her brother's kids. So I'm just going to add them to the group. And she has those 3 items, and she's given to those 2. So I'm going to put 3, and then I'm going to put 2 times 2, because 3 of them, 2 kids, 2 cousins, 3 times 2. And then her kids, 5 kids, 3 items to each, 3 times 5. So if I wanted to turn this expression, make it equivalent expression, but dealing with this, I notice that both of them have 3. I could do 3 times 5 plus 2. And then if I were to simplify this, 3 times 7, and then that gives me 21. But they just wanted me to write it in an expression, so either you would write it, let me use highlighter. Yeah. So I either use this or I could use that. So now, based on what I wrote, use pen, actually no, select. Based on what I wrote, notice that these 2 are the same. But if I were to start off with this and then come to this, what is happening? I know you've came across this word in the previous lesson or in your previous another time, but notice how I took that 3 that was outside and multiplied it to each number inside to give me this. I know I started off with this one, but then I noticed that 3 was a common number, so I just put those two together. So this, a property that we're going to be dealing with that deals with this type of situation. So the lesson that we're going to be dealing with is distributive property. And the objective is, how do we use the distributive property to evaluate and simplify expressions? So before we do that, we're going to review the properties of equality from the previous lesson. Previous lesson. So first one is for any number A equals A, that's reflexive. It's like looking at yourself in the mirror. For any numbers A and B, if A equals B, then B equals A. So that would be symmetric. And for any numbers A, B, and C, if A equals B and B equals C, then A equals C. So that's transitive. And if A plus B equals C, then A plus B may be replaced by C in any expression. So again, that keyword replace, substitution. And then again, you just choose the property equality that matches the example. So for this one, we know 7 equals 7, it's reflexive. N equals 15, you plug it in, so it's substitution, plugging in, replacing. This one, 9 equals 6 plus 3, and then you switch it. That's symmetric. And no, it's not commutative. Commutative is based on if you have an operation between and you just switch the order. But if there's an equal sign, it's symmetric. You're just basically switching what's going on each side of the equation. And then with this one, it's showing you 7 plus 5 and 8 plus 4, they equal each other. And when you simplify them, it gives you 12 and 12 for each. So that's transitive. All right. So let's go into distributive property. Distributive property is multiplying a number by a group of numbers added together will result in the same number as multiplying each number in the group separately and then adding the products. Sounds like a mouthful, but for any numbers A, B, and C, this A times B plus C equals, basically you're distributing the A with the B and the A with the C, and you get A times B plus A times C. So this whole thing, multiplying a number by a group of numbers added together, so you're multiplying a number and a group of numbers that will result in the same when you multiply it separately. So this separately with this and you add the two. So that's what the distributive property is. And based on the example that I showed you, the mother is distributing the 3 items that she has to her kids and then distributing it to her nieces or nephew. All right, so we're going to do examples based on distributive property. So we have the first one. So we see that 8, we're distributing. You could do the arrow to show that we need to distribute. So 8 times 10 gives us 80, and then 8 times 4 gives us 32. When you add those two together, it'd be 112. Even though the 6 is not first, it's behind, you're still doing the same thing. You're distributing. And whatever sign is in front of the coefficient, it's together. So I'm going to show them being together. I highlight that. So this is with this. Whatever sign's in front, you have to keep them together. Do not separate them because you're going to end up with a whole different answer. So then we have 6 times 12, which is 72, and then 6 times negative 3, which is 18, negative 18. Then you do the work, and then that will give you 54. All right, next one. Oops, let me go to select. All right, so distributive property, use the distributive property to help find each product. All right, so most of you might just put this in the calculator and like, okay, I got the answer. But when you're using distributive property, let's say you didn't have a calculator, how would you figure this out? You could do the multiplication work and waste your time, or use a distributive property. Notice how 102 can be broken up into two factors. So I'll show you the steps. You got the 16 out there. The 102 can be broken up into 102. These are two manageable numbers that you can multiply to the number outside the parentheses. And then use the distributive property. So you don't even need to use a calculator. This one, you know, will give you 1600. And 16 and 2 times 2 gives you 32. And then you add it and you get your answer. So if I give you a homework problem, or if it's on a test or a quiz, ask you to use a distributive property based on this example, do it this way. Don't just give me the answer, because you're not going to get any credit. You just, if this was worth, like, let's say 3 points, you'd only get 1 point out of 3, because you need to read the direction and do it based on what I'm asking you for. For this one, we have the 17 out, and then we notice we have 3 and the fraction. This can be broken up. The fractions will be by itself and the 3 by itself. And then you add those two, because when you add those two, you will get this. And you just distribute and you get your answer. This is easier than actually trying to, like, put it into a calculator. You can do that, but if I want you to do it this way, you didn't have a calculator, then this is how you would do it. Basically breaking up the numbers and then applying the distributive property. Alright, so we're going to do a few examples based on that. So we have the 12, and then I can break this into 2, and then plus 0.5. And then I can distribute. So this will give me 24, and I know half of 12 is 6. I add those two, and I get 30. This, same thing, the 27 will be out. The 2 plus a third, 27 times 2, so that will be 54, and then 27 divided by 3, that gives you 9, and then you add those two, that will give you 63. This one, same thing, you put the 9, you can break the 499, so 400, you got 99, but I'm going to break the 99 further. So let me just show the steps. So the 99, I'm going to go further down. So it'll be 400 plus 90 plus 9. Because I want to try to, it's much easier to multiply, especially when you have a 0 and a smaller number, than just do this whole thing. So now it would be 3600 plus 810 plus 81. And then when I add them all up, I'm going to use the calculator for this one. Again, I try to break it down to simple numbers, and I'll get 4491. 4491. And then the last one, I got 7. This one can be broken down to 100 plus 10. And then I just distribute. So this is 700, and this is 70. And this will give me 770. And yes, if you looked at it, you'll know this would be 770. But if I'm asking you to do this by distributive property, do it, please. All right. The next thing, terms and like terms. A term is a number or a variable or a product or a quotient of numbers and variables. So when you have these terms together, they show you, as an example here, you got, this is one term, this is another term. Like terms means that the terms that contain the same variables with corresponding variables having the same power. So you have, these are 3 different terms, so they're not like terms. But you have 3 terms here, and 2 of them, these 2 are the same because they have a square in common. But these 2 are not the same because this one has a square, but this one just has a. All right. I'm going to end here because I'm going to go to part 2 for the next